Hello, ladies. Today we are going to be talking about one of the topics that every individual that is specializing in the aspect of medicine are doing. Today we are going to be talking about blood. What do we know about blood? You can see that blood is a fluid, or shall we say, is a fluid in form of a tissue. That means it is a combination of cells, is a combination of cell 1 and cell 2, or collective or more than different cells to join together and become a single tissue. That means blood is a tissue, and it being a tissue makes it shows that it comes from a cell, or should I say collective cells. Today we are going to look at the first part of blood, and as I said earlier, that blood is a connective tissue. Blood is a connective tissue in a fluid form. You can never see blood as a solid form except it has been clotted. That means if blood is not clotted, it has to be in its liquid form. Now blood, this is the introduction. You can see that blood is a tissue, is a connective tissue in a fluid form, and it can be called the fluid of life because it transports and carries oxygen from the lungs to all parts of the body and carbon dioxide from all parts of the body to the lungs. Now that is the work of the blood, and it can also be seen as the fluid of blood because it carries nutritious and or nutritive substance from the digestive system to the hormones and to the tissues. Now we can also call it the fluid of health because parts of the blood like the white blood cells helps to fight and protect the body against all forms of diseases and gets rid of waste products. Now what are the properties of blood? We can say that blood is red in color. You know that blood is red in color. If we cut our skin now, you will find out that our blood is red. Now we know that the arterial blood, that means the blood that flows in the artery, is scarlet red. That means it's very deep, it's deep red. Now when we cut our skin, we find out that the blood is kind of darker. Why? Because it is the vein that is found on the topmost part of our body, although the arteries is found deep in the fascia of the body. So the blood in the arteries will contain more oxygen, and you understand, it will always contain more oxygen because it carries oxygenated blood from the heart and flows to other parts of the body, while the blood that flows to the vein is purple red because it has more carbon dioxide. That's why they call it deoxygenated blood. We can also see that the volume of this thing in an average adult is 5 liters. Although in a baby we can see that it is 450 milliliters, and as growth increases, as the baby increases, the volume of blood increases. You cannot expect a baby to have more blood than you that are adults. That means as adults you have high volume of blood. Now you can see in females that especially during the time of their puberty and time of their menstruation, that they always find themselves having 4.5 liters of blood because of blood flow. But when they approach the age of menopause, their blood returns, the volume of their blood returns to 5 liters because there is no blood lost. You understand? Now we know that in pH scale that blood is slightly alkaline. As the alkaline because it has a pH condition of 7.4 because it has a pH is pH scale with 7.4. Now 7.4, that means we can say that blood is a base. Blood is a base, is alkalinity. That means blood is not an acid. Some people don't know the meaning. When I was quite younger, I did not even know the meaning of alkaline. But when we grew, we knew that alkaline means base. So we can say that blood is a base. And using it in the scale, pH scale, we find out that the pH scale of blood is 7.4. Now the specific gravity of blood, now in physiology, when we are doing blood physiology, we always find out the specific gravity, that means the influence of gravity on it. Now we can say that the specific gravity totally in the total blood, we are not dividing the blood into sections like in total blood. We can find out that the specific gravity of a total blood is ranging from 1.52 to 1.60 or 1.061. Then the specific gravity of blood cells will range from 1.92 to 1.1101. The specific gravity of plasma is 1.202 to 1.026. Now, what do we know about plasma? Plasma, we can say that it is the liquid portion of the blood, and we can know that blood cells are solid portions of the blood. Now, when we are talking about blood, we say that it is a liquid, it is a fluid. When we talk about blood, we say that it is a fluid. And one thing we know about fluid is that in totality, one of the greatest elements we use in measuring fluid and talking about fluid and measuring it in its alignment is water. So now we know that blood is 5 times more viscous than water. Why is it viscous? That means it's thicker than water. That's why sometimes we use phrases that blood is thicker than water. This is due to the presence of red blood cells and plasma. That means the solid portions of the distinct and plasma proteins. Plasma proteins are the liquid portions of blood. Now, as we said earlier, we said that blood, when we are talking about the composition of blood, we know that blood contains elements. We talked about earlier, the liquid portion, which we know as plasma, and we talked about the solid portion, which is known as the blood cells. They can also be called elements. It's either they are called solid portions or they are called elements. Now, when we are talking about blood cells, we know three blood cells. we know the red blood cells, we know the white blood cells, and we know the platelet, which the red blood cells is also known as erythrocyte, leukocyte, and the platelet is known as thrombocyte. Now, let me explain these red blood cells, white blood cells, and this thing, though they'll be seen as a topic one by one as we progress. Now, red blood cells is one of the solid portions of the blood, and it has a lifespan of 120 days, that is approximately 4 months, and it is reddish in color. It has the presence of hemoglobin, which gives it its color, and the presence of iron Now, the white blood cells, we know the white blood cells are fighters. They are the fighters. They are the ones that fight for immunity. That's due to the presence of antigens. They fight antibodies and destroy all forms of diseases. Now, this platelet or thrombocyte helps in blood clotting. Remember, when we have if you want to try it, you can cut your hands now, and when you cut your hands, when you cut your hand, allow it to dry up, you find out that the blood will clot because of the presence of air in that thing to clot. Now, the reasons for the clotting of blood can be known or can be seen as a result of the thrombocytes. Now, let us go to the next. Now, we are going to go to hematocrit values. Now, what do we know about hematocrit values? I'm going to talk on it shortly. Now, I want to give an explanation so it will be easier for us to understand. Now, hematocrit values is a value of red blood cells in percentage. You understand? Is the value of red blood cells in percentage. Now, how do we find this? If you remove your blood and you put it in, you allow it to centrifuge, you put it in a tube and you allow it to centrifuge. But when you remove it, let me talk it like step by step. Let me say step by steps. You remove your blood, you put it in a hemocritic tube. When you put it in that hemocritic tube, you put an anticoagulant. You put it in a suitable thing, you mix it with the blood so that it will prevent blood clotting. Then you centrifuge it for 30 minutes at the speed of 3,000 revolutions per second. If you did physics, you know what we mean by this. It has to do with rotation, and then you find out that the red blood cells will be under because it's a solid, and the plasma will be on top. Now, the plasma forms 55% of that value. Then in percentage, like the plasma has 55% of the blood and the red blood cells has 45% of the blood. Now, this 45% is known as the hemocritic value. Hope you understand. It's known as the hemocritic value. That is what is known as the hemocritic value. Now, that's the hemocritic value. Now, when the plasma is on top and the red blood cells is below, we find something that separates it. We call it the white buffy coat. The white buffy coat. is a thin layer, and that thin layer contains white blood cells and platelets. That means we know that percentage is measured in 100%, the plasma is 55%, and the red blood cells is 45%. If you add it together, that will give us 95%. Then the remaining 5% is made up of these white blood cells and the platelets. Now, let us talk one by one. What is plasma? Now, I remember I told you that plasma is the liquid portion of the blood. It's the liquid portion of the blood, and it contains 92 to 9, or should I say 91 to 92 of water and 8 to 9% of solid. That means despite the fact that it is a liquid, it also contains some element of solid particles, which weighs about 8 to 9% if we are grading it in this thing percentage. And the solid are organic and inorganic substance that are, let me say, that are sedimented there, and it's one of the important components of the blood. Now we know serum. Now I want to talk about serum now. Now see, serum can be seen as a fluid that comes out from blood clotting. Is a fluid that comes out from blood clotting. Now when blood is shed, we know that fibrogen is converted to fibrin. Why? Because of the presence of oxygen. Now when blood is formed, or should I say blood is gushing out from your skin and is exposed to oxygen, it helps to stimulate the thrombokinesis to convert fibrogen to fibrin. Hope you understand that part. And thrombokinesis is an enzyme, or should I say an hormone, that stimulates the process of conversion of fibrogen to fibrin. Now this fibrin helps to clot the blood, you understand, and keeps it and prevents it from flowing, you understand. It clots the blood. Then after that 5 minutes, we found out that there is a kind of liquid that comes out from that clot blood. Now that liquid is called serum. All these things you can do it in our houses. Just carry a knife and cut yourself and observe all this experience. Now we know that we should know that serum is gotten from plasma. It's just the absence of fibrogen. That means everything that the plasma has, the liquid portion of the blood has, cerebrum has it, apart from fibrogen. Understand? Because fibrogen is converted to fibrin. Understand? During blood culture. Now what are the functions of the blood? Now the blood has different functions. We know it for its nutritive functions. Remember when we were talking about as a fluid of growth, we found out that the blood helps in the transportation of digested food. It carries it from through the process of diffusion to the tissues that needs it at that particular time. That's how God created it. So nutritive substances like glucose, amino acid, lipids, vitamins are derived from digestive food that are absorbed from the stomach and are carried to the blood to different parts of the body for growth and for the production of energy. That means without blood, we cannot have the energy that we have. You understand? Blood will help to transport this thing through the process of diffusion. It will diffuse into the blood, and the blood will carry it to the tissues where it is needed. Now it's also used for respiratory functions. remember we call it the fluid of life because it helps to transport oxygen from the lungs to the tissues and carry carbon dioxide from the tissues to the lungs. I hope you are understanding it. Then we can say that it helps to transport hormones. Hormones are secreted by the endocrine glands, or should we say ductal glands. I can remember back then in secondary school, we know we have the pituitary gland, we have the thyroid, we have the hypothyroid, we have the uh, pancreas, we have the gonads. Now all those things are hormones, and it is blood that helps to transport the enzymes that are produced, the enzymes and the distinct hormones that are produced from those endocrine glands. Now we know that it also helps to maintain water balance through the process of osmoregulation. When we were in secondary school, they taught us osmoregulation, which is the maintenance of the blood of the body fluid of with salt, the maintenance of the body fluid with salt and water. That means the content of salt and water in the body fluid. Now it also helps to regulate the acid and base balance. Remember that the blood is a base. That means a blood cannot be acidic and the blood cannot be over basic. That means it has a medium size, like is somehow slightly different a little from water, which is a neutral distance. So that is a balance that it has kept 7.4. So when you carry your blood to where you see a pH scale and you find out that it is more than that, go to the hospital and check yourself. Now the blood also helps in regulation of body temperature. It helps in the regulation of body temperature. It also helps in storage functions like protein, glucose, sodium, and potassium. Those are things we can understand by ourselves. And remember, as I said, the white blood cells or the leukocytes also plays important roles in development of immunities and fighting of antigens that comes to the body. This will be talked about later when we are progressing in the class. Thank you for your time. Have a nice day.